All right, today we are going to talk about inverse trig functions. And the easiest way I can start off by explaining this is simply, let's say we have, I ask you, what is the sine of 30 degrees? Well, you can go to your unit circle and you can see pretty quickly here that the sine of 30 is going to be the y value, which is going to be 1/2. So your answer is going to be 1/2. All right. Or if you didn't have a unit circle, you would draw a 30, 60, 90 triangle, and you would put 30 degrees there, and 60 there, and 90. This is review. So you'd have 1, √3, and then 2. Sine is your opposite over your hypotenuse. So your opposite would be 1. You can draw an arrow to that. Hypotenuse is 2. Either way, you will get the same answer. All right, 1/2. Now, what we're going to do now with inverse trig is we're going to say backwards. What is the inverse sine of 1/2? And so your answer is going to be 30 degrees. All right. So in this first example, we are giving you, so let's just say your input is an angle and your output, or what you get back, is a ratio of sides, 1/2. In this example, with the inverse trig, now your input is a ratio and the what you get back is an angle. So that is what you want to remember for inverse trig. You are getting an angle back. Your answer should always be an angle. All right, now let me just clear something up from the very beginning here. The inverse sine of x is not equal to the cosecant. They're totally different. All right, totally different. So these things are not the same. So make sure you don't get those confused. Okay, now some of you are probably thinking something, and you're thinking, wait a second, I see another angle on the unit circle that has 1/2 as its y value. I see that one, and I see that one. So, Mr. Parr, which one am I supposed to choose? Am I supposed to choose 30 or 150? All right, for this reason, what we do is we say, well, in order to make the inverse sine of x, and this is a little confusing, in order for this to be a function, you cannot get back two answers. Okay? Whoops, excuse me. You cannot get back two answers. You can't get 30 degrees and 150 degrees, because if so, it would not be a function. How do we know? It wouldn't pass the vertical line test. Let me illustrate that. If we went to, let's just say we'll make this 1/2. Okay? So if we went over here to 1/2 and we had to go up to pi over 6, which is 30, and we also had to go up to 5 pi over 6, which was up here, 5 pi over 6, which is 150, hey, that's a problem, because now it's not a function. It's not going to pass the vertical line test because it intersects two different y values. So the way we do this is we say, okay, for the inverse sine, we are going to only, and this is important, we are going to only give angles back in quadrants 1 and 4. So make sure you write that down. Quadrants 1 and 4. And so for all positive angles, then you're going to be focusing in on quadrant 1. For all negative angles, for all negative values of sine, you're going to be focusing on quadrant 4. So let me repeat that. For positive values of sine, you're going to be focusing on quadrant 1. For negative, quadrant 4. So let's just say we give you the inverse sine of negative root 3 over 2. All right, I see a negative right here. Okay, so since that is a negative, that means we need to be drawing a triangle in quadrant 4. So quadrant 4, we're going to put a triangle in quadrant 4, and we are going to make your opposite side root 3 or negative root 3. We're going to make your hypotenuse 2, and that's 1. And then you have to ask yourself, what angle is across from root 3 in this triangle? Well, it's always 60. So therefore, that is your answer. Now, for these inverse functions, what you want to do is you want to give your answer in terms of a negative angle. So I know that you may be thinking that the answer is 300 degrees. Well, technically, the answer is negative 60 degrees. All right, negative 60 degrees. And that is what you want to do here for this particular example. Negative 60 degrees. All right, let's talk a little bit about what the graph of the inverse sine looks like. You'll see here that this is the graph of the regular sine function, and notice that it is cut off. In other words, we are only graphing not even a full cycle. And once again, the reason why we cut it off is if we, let's just say, we continued to draw this out, and you turned it on its side and drew the inverse, then notice what you would get. You would get a graph that is not a function because it would not pass the vertical line test. So in order to avoid all of that, what we do is we just cut off the sine graph, and that way the inverse sine will be a function. All right, now that's probably confusing for you. It's not a major thing that you completely understand that, but what is important is to pay attention to the domain and range of the original function and the domain and range of the inverse. So let's take a look at this. Let's say the domain of the original function is going to go from negative pi over 2 to pi over 2. So why don't we just say the domain is bracket negative pi over 2 to pi over 2, and the range is going to be negative 1 to 1. And you can see that's the lowest y value that the sine will ever go, and that's the highest it will go. Well, we know from earlier in the year that when you do an inverse, that it's going to switch. So for the inverse sine, the domain is going to be negative 1 to 1. In other words, the only numbers that you can plug into the inverse sine are going to be negative 1 and 1. And as far as the range is concerned, then that's just going to be the same as the domain of the original function, which is going to be negative pi over 2 to pi over 2. All right? And those are basically the characteristics of the inverse sine graph. Notice that the range goes from negative pi over 2 to pi over 2, so that's going to be, once again, quadrants 4 and quadrants 1. All right? So those are the quadrants that you're going to give your answers back in. All right, let's go through these examples here from the notes, evaluating the inverse sine without a calculator. So we're going to look at this first one, inverse sine of 1/2. All right, so inverse sine, that means we need to find what angle has a sine of 1/2. And remember, all of your answers here need to be answers in quadrants 1 and 4 only. All right? So that is the key. Quadrants 1 and 4 only, all your answers. So, letter A, inverse sine of 1/2. So, once again, we did this one earlier, I believe. So you're just going to draw a triangle, and you're going to make your opposite side 1 and your hypotenuse 2, and then you'll be able to figure out where the angles are. So across from 1 is going to be 30, across from 2 is going to be 90, and then this is 60 degrees right there. That's going to be root 3. And so you can see that the angle that we're interested in is going to be 30 degrees, and that's the one by the origin. So that is the answer, 30 degrees. And if you put it in radians, it's going to be pi over 6. So get in the habit of giving your answer in both. All right, letter B. Inverse sine of negative root 3 over 2. Actually, I believe we did this one earlier as well. But we'll do it again real quick here. Negative root 3 over 2. So once again, that's going to be in the fourth quadrant. So we want to draw a triangle in the fourth quadrant. We want to make our opposite side negative root 3, and our hypotenuse is 2, and that's going to be 1. So this is going to be 60 degrees. And since we're rotating clockwise, then your answer is going to be negative 60 degrees, or negative pi over 3. And that's the answer for part B. All right, now part C is a trick question, if I've ever seen one before. Inverse sine of pi over 2. Now your eyes are used to seeing that, and you're thinking 1 because you're thinking of the sine of pi over 2. But that's not what this says. It says the inverse sine of pi over 2. So what does that mean? That means you're looking for an angle that has an opposite side of pi, or 3.14, and a hypotenuse of 2. Now, let's just think about that. That is not a proper triangle. Okay? How can you have a triangle where the opposite side, let's think about this, is 3.14 and the hypotenuse is 2? Do you see that? That is not a correct triangle, because the hypotenuse, by definition of a right triangle, must always be the biggest side of the triangle. So this is an undefined. I'll tell you how else we know. 3.14 divided by 2 is approximately 1.57, right? That is greater than 1. And if you remember from the last slide, the domain has to be between negative 1 and 1. Anything outside of that domain is not going to work. So therefore, this is undefined. Undefined. All right, letter D. Now, D and E, you must pay very, very close attention to, because a lot of students are going to do this. They're going to see an inverse sine and a sine, and immediately they're just going to cancel them out, and they're going to put down pi over 9. Well, guess what? That only works in certain situations. Doesn't work all the time. So let's see if we can do this particular problem here. You always, for these problems, you want to work from the inside out. So let's say we have inverse sine of the sine of pi over 9. Now you're thinking, Mr. Parr, pi over 9 is not on the unit circle. I don't even know what the sine of that is. You're right, we don't. But we do know that pi over 9 is in what quadrant? Quadrant 1. So how do we know that? Well, what is pi? Pi is 180 divided by 9. That's 20 degrees. So therefore, we know that this angle is in quadrant 1. All right, so we don't know what the sine of it is, but it's some ratio. And then the inverse sine of an angle in quadrant 1, the inverse sine of that value is just going to give us right back the angle pi over 9. Okay, so in this situation, these two sine and inverse sine do cancel. Now for letter E, it does not. Let me work this out for you. In letter E, what do we have? We have the inverse sine of sine of 5 pi over 6. All right, what is 5 pi over 6? That is 150 degrees. So let's see if we can figure out what this sine value is. So that's my 150, and 150 is rotated 30 degrees above the x-axis, and that's going to be 60. That's 90. Across from 30 is 1. Across from 60 is root 3, but we have to make it negative because we're going left. And then that's going to be 2. So what is the sine of 5 pi over 6? Well, it's going to be the opposite over the hypotenuse, so 1/2. So this whole inside is just can be replaced with 1/2. And we're going to do lots of examples of this in a little bit. So essentially, what are we trying to find? The inverse sine of 1/2. Well, we already did that in part A. This must give me an angle back in quadrants, let me circle it, 1 and 4. So therefore, 5 pi over 6 cannot be the answer because that's in quadrant 2. So the angle that has a sine value of 1/2 in quadrants 1 or 4 is pi over 6. And that is the answer. All right? So notice in this situation, you cannot just cancel the inverse sine and the sine out and put down 5 pi over 6. That only works when the angle given to you is in quadrants 1 and 4. All right, I spent a lot of time on the inverse sine graph so that the explanation of the inverse cosine, inverse tangent will go a lot quicker. Inverse cosine, same exact principles as the inverse sine, except inverse cosine, okay, inverse cosine of x is only going to give angles back in quadrants 1 and 2. All right, quadrants 1 and 2. Now you say, well, where are they getting this from? Well, quadrant 1, because remember, cosine, don't forget, cosine is your x value. And so for positive values of x, then you're going to be in quadrant 1. Because in quadrant 1 you go right, and that is a positive direction. And then in quadrant 2 you have to go left, so that is going to be the quadrant you use for negative values. All right, so let's just see how this works. We have, well, I'll tell you what, we're going to go ahead and do the same thing for inverse tangent so we can mix them together. Inverse tangent, the only thing you need to really remember about that one is that it is the same quadrants as the inverse sine, 1 and 4. And once again, it's going to be positive values in the quadrant 1 and negative values in quadrant 4. So this is all memorization, nothing more. So let's see if we can do some examples. Let's say we have the inverse cosine of negative root 2 over 2. All right, so what you want to do with root 2 over 2 is you want to start getting in the habit of rewriting that as 1 over root 2. Now you're saying, Mr. Parr, wait. How do you get that? Well, let's just think about it. If you have negative 1 over root 2 and you get the root 2 off of the bottom by multiplying top and bottom by root 2, what do you get? You get negative root 2 over 2. So what you want to do here is you want to think, what was root 2 over 2 before it was root 2 over 2? It was 1 over root 2. Okay? So the reason why you want to write it this way is so that you can identify the sides of the triangle. Okay, so which quadrant are we going to draw the triangle in? Well, I see a negative sign right there. So we're going to use quadrant 2. We're going to draw a triangle in quadrant 2. So we're going to draw a triangle quadrant 2, and remember cosine is your adjacent over hypotenuse. So your adjacent is going to be your -1, your hypotenuse is going to be your √2, and then that's going to be 1. So which triangle have we been studying for a couple weeks now? That is 1, 1, √2. 45, 45, 90, right? So that's going to be 45, and that's going to be 45, and that's going to be 90. Now, you can't put down 45 as your answer because which quadrant are you in? You're in quadrant 2. So you need to put down 135 degrees as the answer. 135. If you put down 45, you're going to be in the first quadrant, and that would be a positive cosine value, not a negative cosine value. So 135. All right. Let's do another example. How about the inverse tangent of -√3? Inverse tangent of -√3. Well, I'm going to write that as -√3 over 1, and that way I can see it being a fraction. And once again, which quadrant are we going to draw this triangle in? Quadrant 4, because it's a negative value. So therefore, we're going to draw our triangle in quadrant 4. I'll do it up here. So quadrant 4. So we're going to draw a triangle in quadrant 4. And what is tangent again? OA, opposite over adjacent. So you're going to make your opposite side √3, and your adjacent 1, and your hypotenuse 2. And so what angle is across from √3 in these triangles? It's going to be 60 degrees. And once again, we're rotating backwards, so our final answer is going to be -60 degrees. And that's the idea. All right, on this last slide, I know we're deviating a little bit from the notes, but you can ask certain questions tomorrow in class. I'm basically just trying to come up with as many good examples as I can to illustrate how inverse trig works. And so on this last slide, we're going to put it all together, and we're going to mix them together and come up with some different problems. So let's say we do, I'm going to make these up here, sine of the inverse cosine of √3 over 2. Oh man, now I've got an inverse trig function inside of a regular trig function. All right, so here's how you want to attack this. You want to attack the inside first. So basically you want to totally ignore the outside and work from the inside. So inverse cosine. Okay, what does that mean? That means we need to give an angle back as our answer. And so we're going to say, okay, which quadrants is the inverse cosine? Give us angles in. Answers in 1 and 2. And this is a positive value here for √3 over 2. So therefore, we're going to draw a triangle in quadrant 1. And let's see what that looks like. Quadrant 1, triangle. And adjacent, so this is A for ka. Adjacent is going to be your √3. And your hypotenuse is 2. And that's going to be 1. So across from 1 is always 30. Bingo. That is your answer. So it's 30 degrees. Now that's just the inside. So what do we have? This whole inside can be replaced with 30 degrees. So now we have a new problem. Sine of 30 degrees. All right, so now we just simply draw another triangle. Pretty much going to be the same triangle that we just drew. But we're going to now put 30 degrees there, 60. And now we have to give a ratio of two sides because this is not inverse sine. This is just regular sine. So that's 1, that's 2, that's root 3. And so what is the sine? Oh, it is opposite over hypotenuse. So that's going to be 1 over 2, 1/2. And that is your answer for that problem. Okay? All right, let's see if we can do another one. And let's see if I can make this one up. How about we'll say let's say the cosine of the inverse tangent of -1. Cosine of the inverse tangent of -1. All right, so once again, we want to work from the inside out. So inverse tangent of -1. Which quadrant are you going to draw your triangle in? Oh, the inverse tangent, it's negative, so we need to be in quadrant 4. All right, so quadrant 4. And we're going to draw a triangle in quadrant 4. And we're also going to write this fraction in any fraction as over 1. And that way we can see that the opposite side needs to be -1. The adjacent needs to be 1 because tangent, remember, TOA is opposite over adjacent. And this is going to be root 2. So what kind of triangle are we working with here? Oh, a 45, 45, 90 triangle. Okay? And so we're rotating clockwise or backwards. So the answer is going to be -45 degrees. But don't forget about this outside part. We haven't dealt with that yet. So therefore, we need to say, what is the cosine of -45 degrees? Well, hey, we already have a triangle drawn. So we can just say adjacent over hypotenuse. What is the adjacent side? 1. What is the hypotenuse? Root 2. So what is my final answer? 1 over root 2. Or if you get the radical off the bottom, it's going to be root 2 over 2. And that is just a couple of examples of various inverse trig problems.